A scientist studying babies born prematurely would like to obtain an estimate for mean birth weight, mu, of babies born during the 24th week of the gestation period. She plans to select a random sample of birth weights of such babies and use the mean of the sample to estimate the mean of the population. Assuming the population of birth weights of babies born during the 24th week has a standard deviation of 2.6 pounds. So that's the population standard deviation. So we can use C. What is the minimum sample size needed for the scientists to be 99% confident that our estimate is within 0.6 pounds of mu? So I hope you wrote down that formula a second ago. But if you didn't, it was that n equals, in parentheses, let me do this, calculator, the minimum sample size is equal to, in parentheses, z alpha over 2 times sigma, whatever sigma is. So what's sigma? 2.6 pounds, so times 2.6, and then all that divided by what? E, my maximum error estimate. She wants to be confident that our estimate is within 2 pounds, so that's her precision. So, or not 2 pounds, 0.6 pounds. So I put 0.6 down there. Now here's the thing. I don't like this because I need to square all this. That's the last part. So what you can do is you can hit enter after you do this and then hit square, or you can arrow outside the division bar and then just put big parentheses around it and hit the squared button. Okay, so the only thing I have to do here now is figure out what I put in for alpha over 2. Well, if I want 99% confidence, that leaves me with 1% uncertainty, which when I divide that by 2 is a 0.5%, so 0.005 is what I put in there. And this will give me my sample size. Of course, whatever it is, I'm going to round it up to the next decimal unless they tell me different. In real life, that would tell me I need 125. Even if it was 124.2, that tells me that 124 is not enough necessarily, so I have to say 125. So I'm going to put in 125. It's pretty easy. Let's hit next. Okay, now I'm going to do it again. Maybe this one will be a population proportion, is it? No, it's still just a mean. So this isn't hard at all. Calculator, again, parenthesis. I'm going to put in 2 parentheses. And what goes inside the parenthesis? Z alpha over something. Or alpha over 2, sorry. Times sigma, whatever sigma is. I'll have to put that in. And then that's going to be divided by my max error of estimate, and then I'm going to square that whole quantity. So a coin-operated coffee machine made by Big Corporation was designed to discharge a mean of 8 ounces per coffee cup. If it dispenses more than that on average, the company may lose money. If it dispenses less, customers may complain. Well, that sounds like a legitimate concern. A Big Corporation would like to estimate the mean amount of coffee, mu, for the population dispensed per cup by this machine. They will choose a random sample of cup amounts dispensed by this machine and use this sample to estimate the population mean. Assuming that the standard deviation of the cup amounts is known to be 0.35 ounces. So let me put in the 0.35 ounces because that's where that goes. Close the parenthesis. Divided by assuming the standard deviation is 0.35, what is the minimum sample size needed in order for Big to be 99% confident? So 99% makes that box 0.005, and confident that its estimate is within 0.05 ounces of mu. So my E is 0.05. Arrow over, close that parenthesis, and square it. My answer is 325.1, but that means we go 326 is my answer. Let's hit next. I'm hoping I have time for one more. I don't, but I'll just split the video. So let's just keep going here. And we'll add this to my pie. One last one, hopefully. It's another, I really want a population proportion one, but it's not giving me it. So let me just do this one real quick. You can read through it on your own. But parenthesis, 95%, so 0.025, arrow out, standard deviation 210, divided by, within 0.5, boom, square it, 67.76, so we'll call it 68. I'm going to hit more practice because I'm really looking for a, nope, that's a mean again. Okay, I guess I'm not going to see it. Let me try once more. I'll go to review. I'll hit this problem, type, and maybe it'll give me a different one. Oh, you know why? This is, okay, in the book it teaches you to do both, but in Alex it only teaches you the one kind. So you're pretty set if you know how to do the one with the mean, but understand also that it's also possible to do for population proportion, and that might come up in your reports. Okay, that's it. Bye.